Hello guys, welcome back. I hope you had a peaceful Easter break. The weather has been nice, so it's actually quite nice to have a break in between the online learning. Chapter 4 in stratified random sampling. This week I like to finish up this chapter, and as well I like to spend the Friday lecture on some of the revision, or I like to look back into your class test. I marked your class test that you have taken last week. Most of you have done very well. I can see you have been working hard, and I understand it is not easy to learn everything online, but you have done a good job. But I like to discuss about some of the questions and highlight some of the points that how you can better answer some of the questions. So we will do that on this Friday. Okay, so I'd like to move on to Section 4.13, the post-stratification. All right, so earlier in stratified random sampling, we mentioned that we would like to have the population. Then we can easily divide the population into different strata, so that within the strata, we can estimate, or within the stratum, we know the stratum size, and we even know the stratum variances, so that we can divide them using different allocations method, for example, like optimal allocations or proportional allocations. And the purpose is that we want to divide the strata so that within the stratum, we know that they are homogeneous, but between strata, we want them to be quite different. So they would be heterogeneous, right? But the question is, sometimes we do not know this kind of information before we actually conduct the stratified random sampling. So let's look at this motivating example in the text. Suppose we wish to stratify a public opinion by gender of the respondent. However, such information would be unknown before the interview. So we would be saying that before we conduct the interview, we don't know how many of them are male or female. So let's say if we can conduct a simple random sample of n people within that population, after collecting all the data from the interview, then we know that there are n1 men and n2 women after the interview. Then we stratify them, right? So in that case, this is not a simple stratification. We can call these divisions of the population is called the post-stratification. So we actually conduct a simple random sampling, obtain some of the information, and then divide them into the sample N1 and N2. So in that case, N1 and N2, if you imagine in sampling scheme, that the number of men and number of women would be a random itself, because every time we collect the data, it varies of the sample size. So N1, N2 becomes random variables, and they change from sample to sample, even though the number of sample N is fixed at the beginning. So this kind of sample is not exactly a stratified random sample. We call that a post-stratification. So we have the Y bar for the mean, and we have PST as the sub-indices to indicate this is a post-stratification. And in this case, the estimated variance of the post-stratification would not be the same as the simple stratified random sampling variances. Okay, let's look at the equations. We try to estimate the population mean. In this case, we are having a conditional expectation or conditional variance, because we would be looking at the expected value given a certain value of the N1, N2, or the sample size for each of these stratum. In this case, we can see that the Y bar post-stratifications would be, again, equals to the summation of each of the Y bar collected from this stratum, adding up weighted by the population size. Okay, so we can see that in this equation, there's no value of the little n to be involved. So the post-stratification y bar would be the same as the simple stratification y bar, because we are not looking at, with our calculations, we are not involving the little n, 1, n2, etc. Unless we're looking at the proportional allocation, right? But remember, in the stratification formula for the y bar estimation, we add up each of the stratum y bar weighted by the population size of each of the stratum, so that, in other words, they would be exactly the same using the same formula as well as the stratification. And the expected value of the y bar post stratification, given the sample size as a random variable, would be an unbiased or a conditionally unbiased estimator for the population y bar. Okay, and the estimated variance that would look a little bit different from the estimated variance for a simple stratifications. So we look at the example, we look at the equations, okay? So the estimated variance would equals to the summation of the variance of each of the stratum, which is the 1 minus the fraction, the sample fraction, multiplied to SL square over NL. So this bit is the stratum estimated variance, right? And we add up each of the stratum variance weighted by the population factor omega WL square. So now we are trying to take out this NL, because NL within each of the stratum or associated with each of the stratum would become a random variable, right? So we want to expand these to take out from the bracket, and multiplying 1 and to the same. So we have WL square, SL square over N square minus, so for the second bit we can cancel out this NL. So for this second bit we don't have NL. Okay, keep expanding these. So if we take out one of the WL, we can even cancel one of the capital NL. So in the second bit of these equations, we would have 1 over n summation of weighting WL multiplied to SL square. Okay, whereas the first bit is going to be the same. So NL in equation 4.13 is a random variable. So we want to look at the expected value of our sample NL. We can find the expected value of 1 over NL. This is given. You don't need to prove that. Is equals to 1 over n, my sample size, weighted by the population size WL plus 1 minus WL over n squared WL squared. So we can substitute this into equation 4.13 to find the expected value of the estimated variance. Okay, so let's do that. Substitute this into equation 4.13 down in here, and then we expand the bracket, and we can keep simplifying the equations, and eventually we come down to equation 4.14 and 4.15. Okay, so in this case, we can easily see that in the first part of the equation 4.15, this is the final population correction factor, right? That is 1, let's look at 4.14. That's 1 minus n over n, summation of the weighting, SL square over n. Okay, so this bit look very familiar, which is very similar to a simple random sampling variance. And the second part of the equations would be the additional variances we need to add back to that post-stratification method. Okay, so I will quickly stop here because we don't have enough time to move further.